Hi, hello everybody. So this is the video dealing with still topic 7.4, multiplying multiple radical expressions. I have divided this into two parts. We saw the first part before 7.4, adding and subtracting radical expressions. This is where we multiply them. We are basically going to see two types of multiplications here under this section. The first type will look like this, where we have a single expression with a single term multiplying an expression with two terms. This is type 1. And then we're going to see something like problem 1923, which is an expression with two terms multiplying another expression with two terms. In both cases, some may or may not include radicals in both expressions, okay? So something like type 1, problem 1922, you do pretty much like you do basic algebra problems. And let me show you an example to remind you of something basic in algebra that would be, multiply. So you may have something like this. Or maybe something like this. How do we do this? So I am sure you know how to do it. The number multiplies both terms inside. So in this case, you would get 3x plus 9y. Okay, in this case, you do it that way. Obviously, in this case, you can always add them first, but you can multiply them first as well. So you have 3x squared plus 6x squared, and then you combine them because they're still like terms, 9x squared. Now, in the case of radicals, it's exactly done the same way. Okay? The most important thing that you have to keep in mind, as we've said it before, because both of these numbers are inside of the radical, they remain inside of the radical. So once this multiplication takes place, you will get radical 18. And this number does not multiply the 5. Why not? The number 3 is inside the radical, the number 5 isn't. So the 5 is going to multiply the invisible one that is in front of the radical. That's why when we multiply this by this, we don't get radical 15, but we get 5 radical 3, as you can see right here. Okay, at this point, they do not look the same, right? We cannot add, but we will try to simplify this, and we do get radical 9, radical 2. Square root of 9 or radical 9 is 3. Radical 2 is just radical 2. And we get to this point where there's nothing else that can be done. This is our final answer because these two are not like radicals. So the operation stops right here. So this is the first case where we have a single term multiplying 2. The other case is where we have something that looks like this. And we've seen it before because it is similar to a problem like this. So how would we do this? Well, we would FOIL. X times x, x times 3, 2 times x, and 2 times 3. At this point, we combine like terms, if there are any. And we check to see if we can simplify anything else. In this case, we can't, we stop. Well, this is exactly the same procedure as with radicals. Okay, we'll do the exact same thing using the FOIL method. But keep in mind, the number that is outside of the radical is going to multiply the number that is outside of the radical. Numbers that are inside of the radical will multiply numbers that are inside of the radical. So in the first multiplication, the 4 multiplies the invisible 1. The 2 multiplies the 2 here. So for the first multiplication, I have 4 radical 4 minus 4 times 3, 12, 2 times 5, radical 10. The third multiplication is 1 times 1, both outside of the radical, 5 times 2, radical 10. And the last multiplication is 1 radical 5 times negative 3 radical 5, so it would be negative 3 radical 25. At this point, after the first multiplication, we are interested in possible simplification. If there are any, yes, there is one here. This is 2 times 4, which is 8. This is 5 times negative 3, negative 15. And these two terms in the middle are like radicals. We can combine them. So I have, because they're both radical 10s. This is negative 12 radical 10 plus 1 radical 10, which is negative 11 radical 10. At this point, we combine the 8 and the minus 5, where we get negative 7, and this expression remains the same. We cannot simplify further. Now, it is very important that you remember at this point that the minus 7 and minus 11 cannot be combined. These are not just regular numbers because the 11 is attached to radical 10. Okay, so do not fall into the mistake of doing minus 7 minus 11. It's a common mistake. Don't do it. We'll stop right here. So these are the two types of multiplications that we're interested in this section. Okay, and we'll go over some problems. I have selected a few problems that we can go over. So 1924 is the first one. So we can do that. So I'm going to copy this problem here. Radical 7, x minus radical 6. So these again will be under either simplify or multiply. And the word simplify is there to remind you that at the end you may have to simplify. Radical 7x minus radical 6. Okay, so this is the first type where I am going to do just that. And keep in mind, there is an invisible 1 outside of the radical if you don't see it. So this does not multiply the 7 because it's not inside of the radical. It multiplies the 1. So I have 1x, or just x, radical 7, minus. But now this is inside of the radical. So the 7 and the 6 multiplied each other, and the 1s multiply each other. So I have 1 radical 7 times 6, 42. Okay. And normally we would see if we can simplify this, the 42, but 42 is just 7 times 6, which is 7 times 2 times 3. There's nothing I can do to simplify. So this would be my final answer. Or if you want, you don't have to write the 1, you can just do this. So this will be perfectly okay. Be prepared, however, for a possibility that you might have something here that we have to simplify. Okay? So that's the first case. Let's see the other problem, 1926. 1926. This is a case now where we have 2 terms multiplying 2 terms, which, by the way, is the most common case. So you may see this on an exam. but you will definitely see something like 1926 and 1927, which I think we'll do today. Okay, so 7 plus radical 6. Seven plus radical 6. 5 minus radical 6. 5 minus radical 6. Good. So this is 2 terms by 2 terms. This is the FOIL method, right? And we'll multiply this by that. Multiply the first times this, but keep in mind, the 7 is going to multiply the invisible 1. So minus 7 radical 6. And that's the case because only the elements inside of the radical multiply each other. Second multiplication. Invisible 1 here, which is going to multiply the 5. 5 radical 6. And now the 1s multiply each other. And because both 6s are inside of the radical, they multiply each other. 6 times 6, 36. At this point, we realize that these two are like radicals. So we'll have minus 7 plus 5, minus 2, radical 6. And this is simplifiable. This is obviously 6 times minus 1, minus 6. We combine the 35 and minus 6. And be very careful. This is the final answer. If you combine the two, 27 radical 6, this will be wrong because this number is attached to the radical 6. So this is incorrect. So you will stop right here. This is our final answer. Okay, very important to remember. Okay, excellent. So 1927, 19.27. And this is a good example because I only see one term here, radical 3 minus radical 10 square. Radical 3 minus radical 10 square. Now, how do we do this? Well, in this case, we'll apply the properties of exponents, which means radical 3 minus radical 10, radical 3 minus radical 10, right? So this is exactly how we would begin the problem. And now we FOIL again. This times that, this times this times that, this times the second. Keeping in mind, numbers outside of the radical multiply each other. So I have 1 radical 9. Professor, do I have to write the 1? No, you don't have to write the 1. I'm writing here because this is a video. And minus 1 radical 30. Right? That would be the second multiplication. Now, the negative radical 10 times radical 3 minus 1 radical 30. Minus times minus is a plus. Radical 10 times radical 10, or the invisible ones multiplying each other is just a 1. Radical 10 times radical 10 is radical 100. We realize now that these two are like terms or like radicals. I can simplify this. Minus 1 radical 30 minus 1 radical 30. Be very careful. This is not minus radical 60. It's just minus 2 radical 30. The operation of addition and subtraction is only performed on the coefficient in front of the radical. And we simplify that. Combine the numbers. Minus 2 radical 30. Do not combine the 13 and minus 2. The negative 2 is attached to radical 30. All you could do is see if you can simplify this. But, 30 is just 5 times 6. I cannot simplify this further. So this is my final answer for this case. All right. So let's see the next problem. 19.28. We have another case where we have 2 terms times 2 terms, but now we have numbers in front of some of these terms in here. So 2 radical 2 minus radical 5. So this is a little bit more complicated one. 6 radical 2 minus 7 radical 5. Okay. Again, 2 terms and 2 terms we are going to FOIL. And same as before. FOILing. Okay. And keep in mind, this number multiplies this because they are outside of the radical. This number multiplies that because they're inside of the radical. Okay. Second multiplication, the 2 and the minus 7. Radical 2, radical 5, radical 10. There's an invisible 1 here. This multiplication now, minus 1 times positive 6, minus 6, radical 5, radical 2. Last multiplication, minus 1 times minus 7, radical 5, radical 5. Okay, all of the parentheses are gone. Combine like terms, simplify these values. So this is 2 times 12, 24. These 2 are like radicals. So minus 14 minus 6 minus 20, radical 10. This is 5 times positive 7. We combine the 2 numbers, 35 plus 24 minus 20 radical 10. And again, do not combine the 59 minus 20 because that would be incorrect. Stop right here. The 20 is attached to radical 10, so you cannot do 59 minus 20. This would be the end of the problem right here, as you see. Okay, good. And our last example, 19.29. Let's take a look at that one. 19.29. This is a simpler version of these problems, 19.26, 19.27, but the answer comes out simpler for one very important reason. I'm going to show you that. So 5 radical 3, 5 radical 5 minus radical 3. So radical 5 minus radical 3 and radical 5 plus radical 3. Okay, so again, this is the FOILing technique because I have 2 terms on the left, 2 terms on the right. But notice that they have exactly the same values, square root of 5, square root of 3, square root of 5, square root of 3, but one is a minus, the other is a negative. So the multiplications are done the same. It's the same foiling technique. But look how the values come out now. So radical 5 times radical 5 is 1 radical 25. Radical 5 times radical 3, 1 radical 15. Minus, there's an invisible 1 here. Okay, minus 1 radical 15, just as the previous. There's an invisible 1 here. And minus 1 radical, minus 1 radical 9. So look what happens now when we're ready to simplify. This is obviously 5. This is obviously 3 times minus 1. And look what happens to the two terms in the middle. These two are like radicals, but this is positive 1 and this is negative 1. So they cancel each other out. And I am left with 5 minus 3, which is 2. Okay, so this is always going to happen when you have the exact same two terms, but with a different sign in the middle. We saw these before, we called them conjugates, and we'll see them again. Okay, very good. Very good. So this was 1929, very important example. So we've covered the two types, the first multiplication with a single term in two terms, and the more important and common problem where we have two terms times two terms, multiplication of radicals.